Welcome everybody, and welcome to one of our Incosi UK paper presentations. My name is John Holtz. I'm the current Technical Director of Incosi UK. And what we're doing with these presentations, there's a couple of them coming up in the next few weeks that will be available for download from the Incosi UK website. It's the papers that got accepted for the conference, but essentially we didn't have time to put in, so they're the reserve papers. They're formally published as part of the proceedings, and this is an opportunity to actually see the authors present the paper that that was originally accepted for the paper. So today we're really pleased to have with us Beth Fitzpatrick from Atkins. Beth has spent the last 5.5 years working at Atkins. She's got a master's degree in physics, of all things, but let's not hold that against her, from Loughborough University. And as I say, the last 5.5 years, she's been working at Atkins as a systems engineer. She's also a member of Incosi. The paper that she's going to be presenting is Delivering Value from Data, a Systems Engineering Approach, which is concerned with, as the title would imply, that it's concerned with, how do we actually go about using data in an effective way as part of our systems engineering approach. So with no further ado, I'll hand over to Beth. So Beth, over to you.
Thank you so much, John. Lovely to be here today. So yeah, it's great to actually get a chance to talk about my paper. So it was all ready to go just in case someone dropped out of the conference back in November. And we blink and here we are in January. So I'm really looking forward to telling you a bit about it. So I'm planning to speak for about half an hour, 40 minutes. I'm going to cover 4 main topics. And like Ben said, pop questions in the chat and then he will field them to me after the talk. So the title, Deriving Value from Data, a Systems Engineering Approach, kind of touches on the broad scope. So first off, I'll do a bit of problem definition. So what was the problem that I was kind of solving? This whole paper is based on a project that I was working on. And so I kind of set the scene, not necessarily just about my particular project, but also about the problem, solution space as a whole. And then the journey to the solution. And this is where I go into a little bit more depth about the systems engineering tools that I used to help get me to where we needed to get to. And then the actual solution itself, a little bit about what was the actual outcome of the project that we worked on, and then the bigger picture, so stepping back and looking kind of at that problem space again from a wider perspective. So that's what we're going to cover. I always like to know where we're getting to. So that's where we'll go through today. So firstly, scene setting. So there is a bit of a famous quote that's often quoted in lots of different kind of websites and articles, and it's all about the large volume of data. And there's this big number that is kind of lauded around, which is 181 zettabytes by 2025. So this was published initially in 2011. So 2025 is not that far away. And actually, let's just think about how much zettabytes is. Never even heard of zettabytes, to be honest with you, but it's 1 billion terabytes, 1 trillion gigabytes, and that is 21 zeros there. So 21 zeros worth of bytes. And when we think of data, this is what you get when you Google on the right. There are lots of images of blue for some reason. There's that kind of brain that will emerge out of data. So there's a lot about AI and thinking, but sometimes you might just think of a data room there. So lots of racks of where data is stored and processed and moved. So recent advances, as we know, over the last kind of 20 to 30 years have increased the amount that we're capturing data, that we're collecting data. And really it's given businesses the opportunity to explore how they might actually maximize the value of it. So let's just think a little bit more about the data. So I've got lots of zeros here, and I've got a bit more of a visual example. So if 1 byte of data is 1 grain of sand, then there's a very random and quite American focused example of how much that is. How much 1 zettabyte of sand is, and that is enough sand to go across the whole coast of the US, as you can see there. So the entire length of the US coast with 1 inch deep and 100-inch wide beach. So there's a whole lot of data emerging. But how are we actually going to use it? What are we actually going to do with it? And that kind of problem space of we've got data, we're paying for it, we're storing it and we're collecting it. How are we going to actually get a value from it? And that is the situation that my client was in, the project that I joined was in, and it's a very common problem. So we've often got lots of different types of users, lots of people sitting at their desk doing their job. But there's kind of a little bit of uncertainty about this data coming along. And often people have lots of questions. If we're actually going to use this data, what we're going to do with it? Is it going to take my job? This data that we're going to start using, is it going to, am I going to be unemployed? Am I not going to have anything to do? Is this data going to is AI going to take over my job? So it's not just technically understanding what's possible from data. It's also going through the cultural barriers to understand how this data is going to transform a business. So there's a lot of different things that we've got to think about. So in this paper, the one that I'm presenting to you today, I give you an example of how I applied a systems engineering approach to help get value from data in this client environment. And it's not just a data science project. There is a lot more other components, and it's specifically where a systems engineering approach is a really useful way to go. So the objectives, so to be really nice and clear about what we're talking about, the problem that I was coming in to solve and looking to help had these three objectives. So the first one was essentially a bit of a framework, a governance framework to help data solutions actually be in existence. So the starting position was that there was no mechanism really for anyone to build any trust in any data solutions that could potentially be created. Secondly, the stakeholders' concerns. So not only was there no framework to help something be developed, there physically wasn't any access to any applications that could be used to actually deliver any data solutions. And finally, it's about building up the trust in any data solutions that this framework carries through, because unless there's going to be trust in the data solutions that you develop, you can bring in a whiz team of data scientists and they can create this amazing solution potentially. But if it's not going to be implemented into business as usual, it's not going to be used, it'll often just end up being shelfware. So that trust bit was really important. So the starting position, as I said, so the client did have an Apache Hadoop platform in place. So there was potential to have the mechanics there, and some businesses won't even have that to begin with. And there was a Power BI kind of app, and that was used to access data solutions, but it wasn't accessible to anyone on the platform. So the end users themselves couldn't use Power BI, they couldn't access the data in any way, shape or form that allowed them to use it. So that second bullet point there in terms of practical concerns, those were concerns that we had to overcome with the governance framework to allow any data solutions to actually be used by end users. So lots of different people, as you can see, and lots of different end users that we had to go through. So if it enabled us to help get to the bottom of how are we actually going to not only work out what value there is in data, but also deliver it to those people, end users sitting there. So the journey that we went on. So first up, I'll just give you a bit of an outline of who. Mentioned client end users. So these are your people who are doing the job on a day-to-day basis. So these are the type of people who might be worried about their job being taken, but fundamentally it's quite important to understand what they actually do so that you can understand how to make their jobs easier really and more efficient and work better. So that's one user group. Second user group that we were up against was our ops and maintenance. So as I said, this was an existing platform that was already in place when we joined the project. So these were people who were contracted to upkeep the existing kind of platform. Basically, that's the Apache Hadoop kind of structure. And those are the people that we had to make sure we're confident as well that these data solutions weren't going to break the platform. It wasn't going to, do a data refresh that was so big that it slowed everything down. And we had to really build confidence in them as well, that they're going to be the data solutions that we're producing, weren't going to break the system. And also security concern was a real big thing for those individuals too. Thirdly, we were very lucky to have some data experts as part of the team. So this is data scientists, we had some data visualizers and some data engineers as well. And these are really great people who were actually thinking about how we were actually going to get the value part of the data. So they weren't at all in terms of what the problem might be or how to deliver it. It was just literally the mechanics of that data scrap, which was really great to have part of the team. And finally, we've got a brilliant resource that we use. So this was a client representative. So they supported the development of the solutions that we were talking about, but they also really were closely respected and as part of that client end user group too. So that was a client end representative for the platform who interacted with the ops and maintenance. So that was a really good stakeholder that we had. So what I'll do now is I will outline the approach that we took to address the client problem that we had and the systems engineering tools, because I know that's what everyone's waiting for. So what I'm going to do is I'm going to explain how we got there, but I'll touch on a little bit of the solution that we came up with, which will be the next part of the presentation once I've kind of outlined the journey. So first thing that we did is we took a bit of a understanding of these 4 stakeholder groups. So it looks really simple here now, but when you first join a project, it's not obvious who exactly are your stakeholders, what are their needs, and what do they actually need out of what the solution that we're working on. There's very different requirements needed from the client end users who actually just want to make their lives easy on their job, to the ops and maintenance who are worried about breaking the platform. And then you've got to understand enough information from the data experts as well, and enough of the information from the client end users. So we identified a development group. This was a mix of different of these people actually from these stakeholder groups. And the idea was to use them to help understand how a representative from each of those groups to understand and be brought into the development of the journey that we were going on. So what we actually set out to do is we took a really easily understandable framework, and that was the Alpha Beta Live framework. So that is government digital services, the way that they've got to, government is mandated to run projects. So you have a bit more development in alpha and understanding, you have a beta phase, which is normally testing, and then you have a live phase. So we took that really simple framework of Alpha Beta Live that was really familiar to everyone we were working with, and we tailored it. We tailored it to be the governance framework for the activities that we're doing. What we also did is we pulled together a champion user group. So these are people mainly from the client end user space here. And these are people who were testing the actual data outputs that we were working on and understanding and whether or not they actually worked in person. So that was really important to get buy-in in that client end user group. So we've got this tailored framework, and we were taking things through this tailored framework. And in order for us to get through the framework and into a live phase for a data solution, we had stage gate or decision point. And for us, we helped them use to bring through a minimum viable product. So agile and iterative kind of methodology was a little bit of an interesting, I guess it had an interesting reputation in the client group. So it was really important that we were delivering something valuable and useful to the client end users so they could build trust, not only for the client end users and the actual data solutions, but also a minimum viable product for the framework itself. So a good understanding of what our tailored framework looks like and whether or not it works. So for us, that meant rolling out Power BI to a small subset of client end users, testing whether or not the access worked and the refresh worked and that everything kind of came together correctly. So security and capacity, access control, folder level restrictions. So what an MVP allowed us to do, it allowed us to build trust in actually all of our stakeholder groups and test and make a better understanding of not only the tools that we've got, but the data and basically the journey that we are on and how much more work we have to do. So once a data kind of a requirement for a data solution kind of came through this business process through the Alpha Beta Live, we did do a little bit of business and mission analysis. So that meant really kind of critically looking at the problem that we were looking to solve, and helping define their requirements, and understand how we're going to get to where it is they need to get to. Because often the client and users didn't really understand what it was they could even do with data. They kind of knew they had to use data and that they didn't particularly enjoy a part of their job, but they didn't necessarily understand what it is that they needed to do. So one of the things that was really key to the whole development of this framework was effectively our stage gate or decision point, and that was the phase entry checklist. So what this phase entry checklist did, it allowed us to move data solutions through the tailored process, but it allowed us to ask the right questions at the right time. So are the requirements defined? Do we understand the data that we need? Do we have the data that we need? Are there going to be any security and capacity concerns? And the tailoring of these checklists is really a key part of the development that we did. So what those allowed us to do is take things through, and that included, in that beta phase, side-by-side comparison analysis, spot checks, deep dives, and it really depended on each solution what was required to move something through the framework and to pass those phase entry checklists. The reason that we were able to be so tailored and to be so flexible with what was required is because we had a real good understanding of who was responsible, accountable, consulted, and informed at each stage. So I've done a lot of kind of theory talking now. So I'm looking forward to showing you and talking through what the actual process looked like. Dun, 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 dun. It looks very simple, doesn't it? And that is the beauty of what we have, how we ended up where we ended up. So as I mentioned, we've got Alpha Beta Live, very simple framework. Really simple for everyone to understand. Are we doing something in alpha? So that's where the request comes in. That's where something is in early stage development and we're really trying to get our head around what it is. Is this even a possible data solution? And in alpha, we might develop some data, we might do some data science, and we might do an alpha version of potentially a dashboard view. And then we have our stage gates to get us through the phases into beta. And beta was probably one of the most important stages because that allowed the trust to be built up in the end user. It's worth bearing in mind that for every single data science solution that we wanted to deliver, we had a specific ask. We had a specific client who was having a problem they wanted to solve. It was kind of rare that we went the other way and we specifically said this is something that we want to do for you. It was very much a collaborative approach. That was really key, that it was use case driven from the user. And because that user will be the one doing the testing, they will need to do a real good check. And this is where the side-by-side and spot checks and deep dives come in. Unless we can really demonstrate that the data science solution that we're developing is as good as the original process, or that it fits into the business as usual of the end user, and unless we build that user trust, there's not much point in moving into live. So in that live phase, that's when we're really content, we're really happy with the output, the data science solution, the business as usual, and it then what rolled out for wider use. So that means that anyone with access to the platform, so with the right data and security access controls, then it's published for everyone to use. So we've got a couple of extra bits here as well. We've got data governance over the top and data operations over the bottom. So as I said, we were really in a great situation on this project that I'm talking about, because we did have existing data governance and data operations. And I think that's really key to help reuse existing processes that are in place. So the ops and maintainers, they had governance processes and we fed into them, we helped improve them, we made sure they were well tailored for our use too. Data operations, it's the same thing. We use the existing processes. We went in and made sure that they work for us too. We influenced them and helped improve them, and made it work as a system in a way that was beneficial for both of us. So the main thing that we particularly tailored, and that was particularly important for setting up this process, was those checklists. So for anyone who's thinking about maybe a different client or a different project, having where you're trying to set up a data science framework basically to help move things through, having good understanding of what that particular business, those particular stakeholders, those particular teams need to have to move a data science solution through whatever framework and process it is, that is key to building trust and building a long-lasting solution, and actually building solutions that actually work too. Because you've got to have confidence all throughout the business. You've got to have confidence with the IT, existing infrastructure that already exists. You've got to make sure that it's integrating into the business as usual business, and for it to be a trusted and long-lasting solution. So what else? Why else did it work so well? So we did have it use case driven. So that meant that we weren't doing anything that didn't have a direct ask from a client. A couple of times we did have a bit of freedom for the data scientists to do a bit of exploration, but it always came down to what is the ask that we've got. And I'll explain in a minute why that actually was so important. Subject matter expert knowledge. So like I say, it's at the right time on those checklists, and we're really making sure we've got the right things that we need. Beta, we were progressively assuring. So it wasn't just the technical side of things, it was also visually. So is it coherent? Does it make sense? Is it giving the right idea? And actually, is it a useful and user-friendly perspective too? And the idea as well, especially with the beta phase, is that we're getting that assurance as early as possible. We're really ensuring that all our stakeholders are bought in, that they understand what's going on under the hood, open and transparent, so they understand really what's going on. And that incremental agile way that we did things. So not, like I say, not only for developing the process, so a couple of users, a couple of dashboards, a couple of data science solutions that we're working on, but also the iteration of the work too. So sitting down with the end users and giving them something that can help them on their journey to understanding more about what they need. So, like I said, we managed to set up this framework. There's over 30 data science solutions now that are live and updating, and it's long outlasted me. I've moved on to different projects, but I'm really happy to say that that framework still exists and the data science solutions are still being produced and worked on. Why does it work so well? Well, what we were bringing together and what those checklists helped define was the right scrap at the right time from data scientists, data architects. So think about the when you're having an early stage development of an idea that you want data for, how is the architecture of the data going to be set up to succeed, especially with those security and capacity concerns. There's lots of nuances in terms of setting up databases and where data's coming in and out, that you need to bring data architects in at that early stage too, and get that tick on that phase entry checklist from them. Visualizers, so that's just once we've created a data science solution, instead of it just being a number that could be misconstrued or confused, we can visualize it together and also take a step back as well and amalgamate data too. But key really is that business and stakeholder knowledge as well. What we were able to really demonstrate and what we kind of saw was how beneficial the systems engineering role was to pull that all together. So this little cyclical diagram here is something that I created, and you might see some interesting and recognizable terms in there too. But what we were able to do as a systems engineer is bring together those three different things that help then increase each other. So data understanding is an obvious one. So you come in, the ability of a systems engineer to kind of really dive into the detail and understand and do that business and mission analysis role on a particular data solution was really necessary to help bring together the data scientists, the end users, into that space to help develop a solution. So that helped us then understand the business. So what is the direction that we're going in? Where exactly do we need to get to, and how are we going to get to the end solution that the business needs to get to? And that also then feeds into the understanding that that user has. So the user then understands the data, and then they're more likely as well to put in a request to do more with their data. And it's underpinned really in trust. So bringing together the trust and the data and the data solutions that we're developing to help deliver the business and the user to work closely. So there's a couple of really interesting things on that diagram, and you might be thinking, oh, that looks familiar to me. Well, this looks very familiar because it is pretty similar to the CRISP-DM model. So this stands for cross-industry standard process for data mining. So you've got business understanding there, data understanding. What we don't have in the CRISP-DM model that's slightly different to what we found was the user understanding. So that's not just the direction of where we're going as a business or what the end solution needs to be, but actually the people who are on the ground, the individuals who will be using the business as usual, or at very least interfacing with the data solutions. Unless they're really bought in and really understanding, they're a key part of what makes this work. So in particular, that beta phase was really important for them, and making sure we have the right buy-in, because unless you're actually testing a solution in the way that it's going to be used in a business as usual, it's not going to be used. It's not going to be replaced, and that knowledge that individual has that they've built up could very well be lost. And the way that they've done it, that knowledge in a business that individuals kind of grow over a long period of time can very easily be lost, and that's what we need to do to retain to help move the whole business forward as well. So we've got that cyclical bit as well, so you can see that deployment going all the way through, and improving the data literacy of the champion user group, especially in our scenario, was designed to encourage more reliance on data solutions as well, and really increase trust and use, really, fundamentally value of the data that the business had. So there's a couple of, you might be thinking as well, I thought there's a couple of interesting points on there, but I feel like I recognize some of them. So this is a screenshot from the IBM design thinking methodology, and I guess it's more of a reassurance that the approach that we applied, the system engineering tools that we used, also resonates with the design thinking methodology. So we focused on user outcomes. We focused on ensuring that anything we created was going to be used by the individuals who are working. So those people who are sat there all throughout the business doing their jobs. Constantly challenging, is there better ways of doing things, and working with them. Do you understand it? Is it doing everything you need? What else are you doing with it? How are you interacting with it? And that diverse, empowered team. So that top right-hand visual where you've got all these different squads, they are all different types of ways of thinking and ways of looking at a problem that we pull together in this approach to help deliver something that was beneficial. So that's the kind of what, that was the result. So like I say, it's still long-standing now, which is great. It's long outlived me, and it's really a journey that any business or project is on to help get more and more value from data. But let's take a little bit of a step back. We were talking about governance to facilitate solutions. We were talking about meeting different stakeholders' concerns. And we were talking about trust in the solution. I think we managed to achieve all those objectives. So that was a great win. But let's take a little think about those individuals within the business, and that were very interesting direction of travel that we all have know about, and especially in the news recently. I'm sure lots of you have seen the news about AI generating, who have basically replaced homework in some schools because you can get AI to generate your homework, for example. So the direction that the brilliant technology is going in is, not surprisingly, can be a bit of a cause for concern for people. So the process and the journey that we were on this project is pretty much the same kind of journey that the whole of the society is really going on, which is, how am I going to actually make the most of this, the value of having data, the value of the intellect or the jobs that data can do. So just as a little bit of a reassurance and a bit more evidence here, we've got a quote from a internal report. So NIST is a US body. It stands for National Institute of Standards and Technology, and NIST publishes lots of things, not only to do with standards, but lots of things about kind of cybersecurity and that type of thing. And this was a report that was published 3 years ago now. The dynamic between AI system and AI user is a relationship, a partnership where user trust is an essential part. And I think that's kind of the nubbin, really, of the journey that we went on this project that I've kind of explained in this paper, and where I hope you guys agree, where a systems engineer is really effective at working through, because there's lots of facets to that trust, not only between the actual data, but between the business and between the situation that we're in, whether it be security and capacity or whether it be business as usual ways of working. So what we found was that the systems engineering toolset worked really, really well, and that the systems engineering skill set as well fitted in really effectively into the problem set that we were trying to solve. It wasn't just practically understanding, stakeholder needs. It was also the ability to apply a systems approach to the actual problem, to the data problem, to the logical conclusions and the logical joining up of all that knowledge as well. So the question really that I like to kind of ponder, and where I'll leave it for today, is, how does systems engineers fit into this future, where the brains and of the AI and the human user are joining together, that dynamic, that partnership. And hopefully you guys agree that systems engineering skill sets are a really good fit. So I'll stop there, John. I'm going to have a sip of tea.
Okay, thanks very much, Beth. Also, it's probably worth people being aware that bit where Beth went da 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 like that, that's going to be available as a ringtone to download from the Encoder UK website from next week. So thanks very much for a really good presentation, Beth. Some really interesting stuff there. We've got a few questions from some of the participants. So we've got, hang on, if I can just open up the chat. There we go. So we've got a question from Jonathan Morgan that says, did you have to make a business case for each data solution, or was the investment pre-approved up to a resource budget cap as a result of a strategic belief that data solutions would be worth the investment? Great
question. Yeah, I mean, in our situation, we were really lucky because the data science team was already funded. So that SQEP for the data science development was already kind of signed off and paid for, and it was really about maximizing the value. So we didn't have any other approvals to actually develop the framework itself. We were we saw that we were actually going to have to get value out of it, and it was a real influencing piece. What we actually ended up doing longer term was, when there was a big data science solution, it had to be kind of justified at epic level. So it was an agile program. So essentially we were able to assimilate the ops and maintenance of the platform itself with the direction of travel for any particular big data science solution. So say, for example, we radically wanted to change the way that data was coming into the platform for a data science solution. We have to influence the development of the platform itself and get sign off through the way that they're developing things. So we were very lucky that we didn't have to justify each particular solution, because it's that difficult thing, isn't it? How do you justify value when you haven't got the trust to deliver the value to begin with? Where do you start on that circular kind of cycle bit that we were luckily able to get around?
Okay, brilliant. Thanks, Beth.
Yeah,
sorry, go on.
I was just saying thank you. Yeah, thanks.
Okay, thanks, Jonathan. We got another question from Sanjeev, who wants to say, can you provide a link to discuss the MVP, minimum viable product, please?
So it's in SEBOC, it's in the CBOC.
Yeah,
the iterative one. What I'll do, I'll find the link and then we can send it out, I'm sure.
Yeah, there was a reference to CBOC earlier on anyway, wasn't there? So
it's the iterative system life cycle process models.
Yes, don't confuse it with most valued player, which is also MVP. Okay, thanks for that, Beth. So we got Lara now, Lara Harris. Can you say how long the project phases lasted? So how long you had to develop the MVP and then do the testing before going live, please? Sure.
Yeah, so it very much depended on the data science solution that we were working on. So one of the ones I can give you an example of was basically the statistics for how many people had done their Microsoft patch updates. So this one was taking up quite a lot of people's time, and it was identified quite early on that they want a data science solution because the data was there. And there was quite a bit of stakeholder engagement, particularly in the beta phase, to make sure that we had the right individuals. So I think we did 3 to 4 months worth. So the stats are produced on a monthly basis. We did 3 to 4 months worth of doing deep dives, of doing side-by-side comparison, of really verifying exactly that we were really happy. So probably talking 6 to 8 months for something like that, but that then transformed 4 man days a month, human days a month, once it was in live, and drastically reduce the burden of human beings on that one. But some of them were really quite small. Some of them were, well, I just want to visualize my data in a better way and be able to make things easier. We develop a dashboard in a couple of weeks. We'd do probably a month or so of beta testing to make sure they were happy with it, and depending on other types of work, so anything from 6 to 8 weeks up to 6 to 8 months, really, depending on the size of the data solution. And actually, if we needed to onboard data, we're talking a much longer timescale, because then you have to put that data onboarding requirement into the backlog for the data ops team to work through and prioritize. So really big scale of different types of things.
Okay, brilliant. And I think we've got time for one more question. So this is a question from Steve Beard. How did you overcome the under and over trust of the information systems? Do your systems show their workings or provide justifications for their results?
Sure. I mean, absolutely. That's very much a big part of it. So the beta phase in particular is where we are able to break down exactly how things are working. So when an individual came to us with a problem, we then sat down with them and understand and worked out exactly what it is we needed to do. The workings of justification were those deep dives and those technical assurance sign-offs. So that is, you manually do your calculation, and we'll show you the calculation of what the data science solution is, and then we will literally color code and work out how similar things are and what's different. But the end user is very much working with us on that, and that's where the trust is built, because they're not having any wool pulled over their eyes. It's transparent, it's open, and actually they have to be confident to sign off. Of course, we do have lots of caveats on the page to be like, this is exactly what this is, because when something goes out to live, anyone can access it on the platform. So we have real clear understanding of what this is and what this isn't, and obviously who to contact to find out more. But particularly it's about sitting down with the person who's asking for it, and it will be their business as usual, to show them under the hood, and really their knowledge is often way more valuable than what they're going to gain necessarily. they're not learning necessarily from the data science. You need their knowledge to help them be able to take it on. So it's not just a one-way street in terms of beta testing. You really need end user interaction, but also that helps that they also then trust you more as well, because they've understood it fully and helped you with that assurance piece.
Yeah, excellent. And I guess that whole, what's come through all the way across this has been the whole stakeholder engagement for everything that you've done. And I think that's, a key aspect to everything that we do in systems engineering. And I think everybody can take away part of the message from that. So, well, thanks very much, Beth. That was a really, really excellent talk. I hope everybody's enjoyed it. I'm sure Beth would be delighted if people want to constantly email her for the next couple of weeks with other questions that they think about. This will be made available on the Incozy UK website. So formally on behalf of me as the UK Technical Director, and also on behalf of Incozy UK, Beth, thanks very much for taking the time to come talk with us. It's been an excellent presentation, and we hope to see everybody soon. Okay, thanks very much.
Thanks so much, John. Lovely to see you guys all.